Hello everyone, Advik Yadav this side. As we discussed in a previous video, we're gonna start our EGU series right here. The first topic which we are going to cover is our oh my god, I just forgot the name of the topic. Projectile motion. Projectile motion, and I really love this topic, and I will really like to explain about projectile. Oh my god, I messed up. Projectile motions. Don't go my writing. Will will improve. Will improve. Failure is a part of success. Projectile motion. Hope you understand. Okay, so let's start. So, according to me and according to the book, I would say there are two types of projectile, which is one in layman's language, a half projectile, which goes just like that, and one in one my language is a semicircle, which goes just like that. Oh my God, my drawing is so messed up. I have to bring take drawing classes. Okay, let's just mention them R just for a while so that I can explain you. Just a second. Yes, and this has H. I will explain you in a while. Just a second. Let me draw because my drawing is not that good. So yeah, I completed the drawing. So basically what's happening here is there is an object, okay, which is thrown with a u meter per second velocity, okay. Basically, let's take it from the, from the basics. What is projectile motion? Projectile motion is a name given to any body which is thrown into a space, okay, in some space with some velocity into it, okay. You have thrown some ball or anything into some space, and the motion of that object is known as projectile motion. So there are various examples of projectile motion, a javelin thrown by an athlete, an object dropped from an airplane, a bullet fired from a rifle, a jet of water coming out of the side of the hull of the vessel, a stone thrown horizontally from a top of the building. These all are the examples of our projectile motion. And well, you know what? You know what? I am also like astonished by the fact that we do not take in account of the air resistance, the effect of gravity, which is on the object on different levels of height. We just take the gravitational constant, which is, sorry, not gravitational constant. We just take 9.8 meter per second, which is the force which is the Earth pulling the object. And yeah, the motion along the horizontal direction is with uniform velocity, and the motion along the vertical direction is under gravity. Okay, so the motion which you are taking here is gonna be of constant velocity, so it's not gonna vary. Okay, it's gonna be constant v. Okay, and the motion right here is going to be downward, which is g, and we're going to take this motion g. Yeah, moving on. Projectile motion has various forms, as seen on the screen. One is a half projectile, another one is a full projectile. So both have their own abilities and own disabilities. Let's get into it. Let's start with the small one first because I think it is the best out of all. What is the small one? Let's just divide the page here between them two. Okay, so the small one. The small one, you know, as we just thrown an object from here with an initial velocity u, the object travels and travels and travels, come here and drops it at this point. Are understanding? The object travels and travels and travels and get dropped at this point. This point right here. The amount of distance traveled from its initial position. I'm repeating myself. The amount of distance travel from its initial position, which is this one, till this one is known as r. So if we perpendicularly see this one, which is right here, if we just drop the object on the ground rather than in the air, so the amount of distance from this, ground level to the point where it dropped is known as R. The range. It's the range. As the name suggests, the range of the object. So, moving ahead, we got cleared with the range, I guess. The amount, you know, the amount of distance the object traveled. Let's just take a different color here. This one, yeah, it's pretty vibrant. Okay, moving on. So it's also referred as y many a times. So y being, you know, the amount of distance traveled if we just extend this line right here and drop one perpendicular line. Oh my man, it doesn't look like a perpendicular line at all. Let me make it once more. So if we drop a perpendicular line just like that, I know I'm struggling, but failure is a part of success. So if we drop one perpendicular line, I guess you will be able to understand. We're gonna get y. Okay? We're gonna get y. So many a times y is equals to range. It depends, really depends what the question is asking. For example, if the object is here, then y is going to vary. So y is gonna be this distance between the object from this point. Okay? It's not x. Remove x for now. Okay? So it's gonna be this difference. So I guess we are cleared with the y. So y is nothing but the distance, you can say the perpendicular distance from this point to this point if we are asked with any position on the projectile. That's clear. And the formula is y is equals to half gt square. Okay, so g is going to be the gravitational force which is exerted on the object by the earth, and t is the time traveled by the object from going from here till here. Okay, the time travel from the object to going from here to here. That's pretty good. Fine. Moving ahead. Let's take another color. Okay. So it's gonna be the horizontal distance. hmm Okay. Let's take x now. X. X is equals to initial velocity into time traveled. Okay, ut. So, for example, initial velocity is u, and the time taken from reaching here to here is t. We're gonna get this distance, the height, we can say, the height. Not specifically height, but it's just a way of representation of height. It's not height, it's just a way of representing that it's height. Okay. I mean, not height. Oh my God, I know I messed up. I messed up. I know I messed up. I messed up. Yeah, oh sorry, it was the height. It was the height. Okay, so that's gonna be so the distance from here to here is going to be x. We can, relate it from yeah, this diagram is getting worse and worse. Let's move on to the next one. Okay, the object is here with makes this projectile. Okay, and if we traveling with u. Okay. Yeah, I got the diagram right now. So x is equals to formula u plus t, u into t. Y is equals to half gt square. Okay, gt square. Now let's just divide the plane into. That's a straight line. That's a straight line. That's a straight line. That's a straight line, my friend. That's a straight line. Okay, moving on to the second one. How second one relates to first one? So we have two here. One projectile we just got explained about, which is this one, and now we are gonna talk about this one. Let's see how it turns out. Okay, but here, what is happening? The object. Let's just draw one more clear diagram. I am really, really sorry for my drawing. I will improve. I will improve with time. Okay, so we're gonna make the edge here.